Okay, so last time I asked you to do quite a few problems, right, to turn in today for a quiz grade, right?
I didn't know it was a quiz grade.
I went back and watched the video, and that's what I said. So, and I said you don't have to do all of them, but I said do an honest attempt at it, right? Try and get enough done to feel comfortable. But I have been asked about these two questions in particular, so I'm going to talk about these to start class. So the first one you asked for, and the instructions here are to use a calculator to approximate the value of each of these expressions, right? Yes, yes? All right, so let's first interpret what this is saying, right? This right here is really saying to us to find some angle, right? This is some angle, right? This is an angle, because an inverse function always returns to us an angle. So what angle, right, when we take cotangent of it, do we get negative root 5? That's really what that's saying to us, right? Now, the cotangent function has a domain, the inverse cotangent function has a domain restriction. Just like all of our other trig functions, in order to have an inverse, you have to have a domain restriction. So the domain restriction we have for cotangent in order to have an inverse is that our angle that we get, our answer, must be between 0 and pi. This goes back to the picture of cotangent. If we were to graph cotangent, here's pi, here's 0. Cotangent looks like this. This is what cotangent of x looks like. Are we good? Now it continues, it keeps on repeating itself, but we picked this little period of it in order to define the inverse. So our answer, whatever our answer is, needs to be between 0 and pi. So what we're saying is where in here, at what angle, when you plug it in, do you get negative square root of 5 to come out? So the yellow grade should be somewhere over here, like somewhere in here. Don't know where, but somewhere in here, I plug in and I would get a value of negative root 5 to come out, right? Yes? Yes, yeah. All right, so does anyone want to help us now? This is just to understand what we're asking, right? This means find the angle when you take cotangent of it, you get this. So what did I tell you all to do in class now? Because you don't have this key on your calculator. You don't have cotangent inverse. Convert it to tangent, right? So this is really saying tangent of some angle, right, is equal to what? Not this, what? The what? 1 over it, right? The reciprocal. So 1 over negative square root of 5. You good? That's just using the fact that cotangent and tangent are reciprocals. Now, this, I can convert this now back to an inverse statement by saying that tangent inverse of negative 1 over root 5, right, is going to be the angle that we're looking for. You'll need to let me know if this is not making sense. We're starting with an inverse trig function. We're trying to evaluate an inverse trig function which gives us an angle. We convert that inverse to a regular trig function. Then we use the reciprocal property to convert it from cotangent to tangent. And then we use the property of inverse to convert that back to an inverse statement so I can use my calculator to get this. Right? So put that into your calculator. And I am in radian mode on my calculator. So I'm about to do tangent inverse of negative 1 over the square root of 5. And I get an answer of negative 0.42 is equal to theta. Yes?
Would degree also work?
Let's do it in degrees as well. Let's do it in, does anyone have it in degrees? What'd you get?
Negative
Negative 24.09 degrees is theta. All right. Now, I just erased what I needed to show you. Shit. Okay, where did we say our answer was going to be? Right? It went like this, right? And this was pi, right? And this was 0, and this is pi over 2. And we said that our answer should be somewhere over here, right? But where's our answer? Where's this? Negative. So think about the reason this is happening, okay? And so this is not the correct answer. This is not right. The reason why it's not right is because we switched this over, right? But as soon as we go to inverse tangent, what's the domain restriction for inverse tangent? It's a different domain restriction, isn't it? It's negative pi over 2 to pi over 2, right? So do you agree it's never going to give us an answer over here? So this is I know why you're asking this question. This is a complicated problem. So let me try and help you see it this way. Right now, going back, let's look at this right here. Let's look at this right here. This said that tangent of some angle is this number, right? A negative number. And the answer to this is that our angle should be negative 24.09, which means that's negative 24.09 degrees. Y'all good with that? Sure? Tangent is which coordinate divided by which coordinate? Y over x, right? So if I wanted to, right, to help me see this, I could look at this fraction as the y coordinate over the x coordinate, something like that, like this ratio. Now, if I am in the fourth quadrant, which of them is positive, which of them is negative? The y or the x? The x is positive and the y is negative, right? So I would put the negative up top and put this like this. So I have a negative y coordinate and a positive x coordinate. Yes? I'm doing this for a reason. Just follow me through here. So my x coordinate would be root 5. My y coordinate is negative 1. Do you see how this picture matches this statement right here? Yes? Okay. But we already know that that's not the right answer, right? We know it's not the right answer because our answer should be between pi over 2 and pi. So is there anywhere else where this could happen, where you would have this same ratio happen, but somewhere between pi over 2 and pi? Do y'all see where it is? The second quadrant. That would be, out of colors. Couldn't I just go straight across like this? What would the x coordinate there be? Negative root 5. And then the y coordinate? Positive 1. Right? Now, if we're here, what's cotangent of that angle? If tangent's y over x, right? Right? Then what's x over y? Negative root 5 over 1, right? Negative root 5 over 1, which is what we want, right? We want this. So this is the correct angle. See, this one, it was in the wrong quadrant. That is the biggest drawback of inverse tangent functions, or inverse functions on your calculators, is that sometimes your answer is not in the correct quadrant, like in this one. So we have to realize that we can get the same ratio here if we move to this quadrant. And then we're within the domain of the cotangent inverse function. Wouldn't it be nice if we just had a cotangent inverse button? Sure would be nice, right? But we don't. So we have to figure out what this angle is. And this is actually a good problem because this is what I'm going to start class with today. Can y'all tell me what this angle is right here? What is that angle?
180 subtracted by 24.
Very good. It's 180 degrees. Take away this much, right? Because whatever this angle is, this distance right here, whatever that is, that's that same distance right there, isn't it? So if this is 24 degrees this way, that would be 24 degrees. So if we take 180, which is a half rotation, subtract the 24.09, then that would give us that angle. Can someone do that, please? What would that be? 155.9. Wait, 155.91, right? Degrees. What number was this? 27? 27. Y'all look confused. Is that safe to say, or? I'm going to do another one that's just like this, because you asked me about the other one. It's exactly the same sort of setup. This was 8.2. Okay, 8.2. So what's the final answer? 155.91 degrees. Or if you convert to radians, you would, if you want to do radians, what you would do is you would take pi and subtract this number. Or subtract 0.42 from pi, and that would be the angle. Let's do the other problem that I was asked about, because it's the exact same setup. Maybe this will go a little bit smoother and faster. What was it again? Cotangent inverse of what? Negative 3 over 2? All right, so this is asking for an angle, right? That when you take cotangent of that angle, you get 3 over 2, right? That's what this means. Cotangent of some angle is this. Now, this means tangent of some angle is the reciprocal of this. And that means that the angle should be tangent inverse of this on my calculator, 2 over negative 3. And so when you do that in your calculator, let's do it in degrees. Tangent inverse. Man, this thing is, my calculator's having issues. Negative 36.69. I'm going to go negative 33, not 33.7. Let's do that. Negative 33.7 degrees is what the angle should be. But we have the exact same problem that we did before. This right here, this angle, whatever this angle is, right? This theta that we get has to be between 0 and pi. That's the domain restriction for cotangent inverse. So you can't tell me that the answer is this, right? So what I'm going to do is I'm going to, again, kind of draw a picture and realize that it's telling me I'm down here, right? It's telling me I'm down here, that my angle is negative 33.7 degrees, but I actually need to be directly across from that. I need to be over here. So I need this angle instead. So last time, didn't we subtract? We did 180 and we subtracted 33.7? So we did? Couldn't you also just add 180 to this? Same exact procedure, isn't it? Adding 180 would just take us to the other side over here. Either way, I'm going to do it the way we did last time. I do 180 and I take away the 33.7, and that is 146.3. That's your angle. Does that help? It all comes to the cotangent inverse domain stuff really tricks students, and I understand why it does. Okay, it's because in order to do this, I have to use the tangent inverse key, but that forces me to be between negative pi over 2 and pi over 2, but my answer needs to be between 0 and pi, so I have to make sure that I'm in the right quadrant. All right, any others before I collect it? Yes? 63. Tangent of sine inverse of u? That one? Okay. Tangent of sine inverse of u. And the instructions here are to, make sure this is all on. Yeah, to rewrite this, basically turn this into something with algebra instead of trig stuff. And I did, I think, 1 or 2 of these in class, right? So the first thing I'm going to do is I'm going to call this here theta, right? Because sine inverse of something should give me an angle. So I said in class last time that this means ultimately we want to know what tangent of theta is, right? That's what we want. What do I do next? Someone can help me. Do a triangle. What's my triangle going to be based on? What do I do? I use this right here, right? This statement right here, that theta is going to be equal to sine inverse of u. That is equivalent to me saying that sine of some angle is u, right? To say that sine inverse of u is theta means that when I take sine of theta, I need to get u. And this is where I build my triangle from. I rewrite u as u over 1. I draw a right triangle. And this is my angle theta. Sine is opposite over hypotenuse, right? So this will be u, and this will be 1, right? Opposite over hypotenuse. And now I want to know what tangent of theta is. So the only thing I need to get tangent is the adjacent side, right? If I can figure out what this is, then I can do opposite over adjacent. So I need to figure out what A is. I already have two of the 3 sides. So I write down the Pythagorean a squared plus u squared is 1 squared. That means a squared equals 1 minus u squared. So I'm just solving for a here, moving that over. Take the square root. That's what a is. So that goes here. And then to answer this question, what's tangent of theta? Opposite over adjacent. So this should just be u over the square root of 1 minus u squared. Does that help? Okay. All right. Anything else?
Number
13? So this, they want you to find the exact value, right? Not approximate. Exact value, secant inverse of 2 root 3 over 3. Secant inverse of 2 root 3 over 3. Okay. All right, so we're just going to play the same game we've been playing, right? This is an angle, right? This is an angle. Some angle theta. Right? That's some angle theta. And what I can tell you is that that means that secant of that angle has to be 2 root 3 over 3, right? This, I can use the fact that secant's the reciprocal of cosine, right? I can do that reciprocal. And so I can say this is really cosine of some angle is what? That flipped over, right? So 3 over 2 root 3. Yeah? Now, they want the exact answer, right? So they don't want me plugging away on my calculator right now. They want to know if I recognize this as a common angle. So do you know on our unit circle, do you know anywhere that cosine of an angle is this number? Well, that number shouldn't look familiar to you. Like, not the way it's written. That doesn't look familiar, right? Cosine is which coordinate? The x-coordinate. So somewhere on the unit circle where that's my x-coordinate. Doesn't look familiar, right? Unless you do what?
Rationalize.
You have to rationalize this. If you rationalize this, look what happens. 3 over 2 root 3. Multiply the top and bottom by root 3. And on the top you get 3 root 3. On the bottom you get 2 times, what's root 3 times root 3? 3. Do you see that on the bottom? 3. And then do you see those cancel? And so that's just a very tricky way of them hiding this number from you. See? They hid that number from you. But that's really what that number is, right? So do you recognize this? Yes? That should be a common x-coordinate. So where on the unit circle is our x-coordinate that number? Yeah, it's over, where is it? Our x-coordinate is positive, right? So right here? Right there, right? At pi over 6? But isn't it also that same x-coordinate down there as well? Right? It is. So which of these is it? Why the first one?
Because it would be negative from the fourth quadrant.
Well, it's the x-coordinate, right? Isn't cosine the x-coordinate? Right? And both these points have the same x-coordinate. Right? This has the x-coordinate of root 3 over 2, and then the y-coordinate's 1/2. This one is root 3 over 2, and then negative 1/2. So why is it this answer and not this one? The domain restriction. What's the domain restriction for secant inverse? You have to look back in your notes, or you have to remember, it's the same as the domain restriction for cosine inverse, which is 0 to pi. 0 to pi. So we are not allowed to look in here because of the domain restriction. This theta we have that we get here has to be between 0 and pi, because that's the domain restriction for secant inverse. It should, if you look in your notes, somebody look, are you looking? No? Do you see that anywhere for secant inverse?
I do.
It's on there?
I got it from the math lab.
Okay, the math lab had it?
Yeah.
But I should have put it here at some point. I did put it here. It would have been in your notes where I wrote, if secant inverse, sorry, I would have written this. If f of x is secant inverse of x, right, then, what did I write? The inverse, sorry, this is cosine. Then f inverse of x is secant x, right, as long as, what did I have? Yeah, it was 0 to 0 pi over 2 union pi over 2 to pi. So basically the only time we ever run into a problem is at pi over 2 because you get division by 0. But the domain restriction is pretty much from 0 to pi except for that one number. So that's why we have to be between here and here. Does that help? There's kind of two things in this problem that you have to be aware of. First, you have to be aware that this turns into the cosine, then you go look at you're going looking for the x-coordinate. And then you have to kind of realize that they're trying to trick you here by hiding it from you, right? So you rationalize top and bottom, then it's easier to see it. Okay, let's move on. Okay, so I'm going to have you turn in whatever you have, right? I asked you to do that, so for those of you who did it, I want you to get credit. If you don't have anything for me today, you can still turn it in next class, but I'm not going to give you full credit. All right? But it's better than having a 0. All right, so who has something for me today?
I still have like 8 problems left to do. Like, would it be better?
I would turn in what you have, and then if you want to add to it next time, you can add to it next time. How about that? Anyone else? Thank you. Make sure your name's on it somewhere. Thank you.
Oh, this book work, and and it
I'm gonna eat it.
Sure, okay.
I have 2 more to do, but that's fine.
Yeah, I would just turn in what you have. Make sure your name's on the first page.
I didn't state that.
It's okay. I'll keep them together. Anyone else? Oh, sorry. Let's see those there. Thank you, thank you. Thank you. Thank you. We're good? All right. Let's get on to today's material. 8.3. Trig equations. Okay, this is, I told you on the beginning of class, this is a very important section. It's like, there's a lot of things I really want you to know in this class, but this is really one of them. This is a big one, all right? This is what I tell my Cal 1 students. I told you all that, right? First day of Cal 1, I say, you better know your unit circle, you better know how to solve trig equations. So before we start it, I want to get a few things clear in terms of angles. Let's say that I draw an angle here for you in red. This angle here, let's say I call that theta. And let's just put a point at the end of that right there. That point has some x and some y, right? Then if I were to reflect that point over into the second quadrant, where I just keep the y coordinate the same, but change the x coordinate negative like this, and draw that, that'd be negative x and positive y. See, right? Just reflect it over. Can you tell me what this angle would be in terms of theta? So if this is theta, then what would this angle be? Like from here to here? 180 minus theta, right? So all the way from here to here is 180, or pi. And then you're just going to subtract theta. So there's almost like, there's not really a theta here, but you can kind of imagine that this is really kind of like theta right there. That's a dotted theta. See there? It's kind of like that's theta there. And so you're subtracting that theta from the 180, right? Okay, so I'm going to write that down. This right here, this angle right here, would be either 180 take away theta if it's in degrees, right? Or it would be pi take away theta if it was in radians, right? It's one or the other, depending on how I give you theta, right? We all happy with that? Now, what if I do this? I reflect it, let's reflect this down to this. So in other words, just take this red line and go straight across like this. Right? Now that point is negative x, negative y. So now your theta is right there, right? Like my little dotted thetas. So what would this angle be? The one that goes from here to there.
Theta plus k.
Theta plus, it's this theta, but I'm just going to here. I'm not going around over and over, just one time. So from here to here, I would just have to add 180, right? You could say 180 plus theta, right? Or you could say theta plus 180. There's 2 ways of looking at that. So this angle right here would be 180 plus theta if we were talking about degrees, or it would be pi plus theta if we were talking about radians. Y'all follow me or not? Yes? I'm out of colors. I need a green. Wait, you know what? I think I do have green. I don't. What the hell? I picked all the colors today, and now I've lost them already. Oh well, we'll go with red again. So now I'm going to reflect it down here. So now you're positive x, negative y. So now it's almost like your theta is this angle from here to here. So what would this angle be? This is starting to turn into a mess. The angle all the way around to there. What would that be?
360 minus theta.
360 minus theta, or in radians, 2 pi minus theta, right? So it's like all the way around is 360, but then we're going to take away this theta, right? Or you could say all the way around is 2 pi, and then you take away theta. So that final one here is 360 degrees minus theta, or you could say 2 pi, take away theta. So I guess my point is this. We should be able to take angles and reflect them into different quadrants and know what those angles would be in those other quadrants. I'm going to give you one example before we move on. So let's say I gave you this right here. Let's say I said go over 4 down 3. So I gave you this point 4, 3, and 4, negative 3. Right? And so this is going to be some angle in here, right? Let's call it theta. Would that be a positive angle or a negative angle, you think? The way I have it drawn from here to here, that would be a negative number, right? So let's just say that we knew what that answer was, all right? Could you figure out, from that, could you figure out what this angle is? That's supposed to be a straight line. Could you?
Yes.
Yeah, you should be able to, right? Let's say I can actually do this on my calculator. I can tell you what that angle is. I want it to be correct, so let me tell you. That angle is, I'm doing inverse tangent of negative 3 over 4. That angle is negative 36.9. Negative 36.9 degrees. That's the angle right there, from here to here. So can you give me this angle that goes from here to here? What would you do?
180 minus 36.9?
Yeah, you just do 180, from here to here is 180, and then this angle right here should be this but not negative, right? Like you're looking at like an absolute value. That's 36.9 degrees. So you go 180 and then take away that. So 180, take away 36.9. Why am I putting that in there? 143.1 degrees. We'll get more practice with this, all right, as we move through these. All right, here we go. Buckle up.
I have a question.
Yes.
So if we reflect the negative 36.9 across the y-axis to the third quadrant, how is that?
If we reflect it,
Like, if we get it to the third quadrant, like how does that?
I'm not sure I understand what you mean, reflect the angle. Like this angle goes from here to here, right? Goes from there to there. That's that angle right there?
I don't know what I was asking.
Are you sure?
Yep, positive.
Okay.
Going on.
Okay. Then I,
You meant if it went this way, like down into the reflected.